So a few reminders. The homework 4.1 is due today, and then the next one, 4.2, is due on Wednesday. Oh wait, is that correct? Oh no. So this one should be part 1. This one is part 2. Yeah, okay, so 4.1, part 1 due today, 4.1, part 2 is due on Wednesday. And another thing, so I want to say, if you want to ask me questions about web work, make sure to send the questions along with your work. Don't just ask me, how do I do, what do I do? Send me questions with your work. Because if you don't, the first email you get from me is, show me your work, and I don't want to waste your time doing that. So yeah, if you have any questions, send me email and show me your work. I want to know that you put into effort, and it's also easier for me to see what you don't understand, so that I can help you better. And what else? Okay, and this is the information. So about the second exam. The second exam will be on April 10, Friday. The time limit is 3 hours. It will be available on D2L from the whole day. And then the topics cover section 2.8 all the way up to 4.3. So yeah, unless you're confident enough to start the exam, don't click the button until you finish reviewing everything. But yeah, if you haven't checked out my email from Friday, make sure to check that. So I basically say that I won't reply any emails related to the course content on that day. And if you have any technical issues, you should email me and I'll reply as soon as possible. Any questions before we start? Going to be like the quizzes. Let me think. So, okay, so I know that there will be a lot of multiple choice questions. I think 40% of them is multiple choice questions. And actually, let me get back to you on Wednesday. I haven't looked at the exam yet. So let me get back to you on Wednesday. By the way, so we're going to do sections 4.2 today, and then I'll finish 4.3 on Wednesday. Then we'll start doing review on Friday and the following week. So yeah, Ryan, I'll get back to you on Wednesday on that. Any other questions? Okay, so section 4.2, this is about definite integral. And I'll explain in a bit what it means by definite. And this section is about computation of the integral using the area definition. So compute integral using the area definition. So what do I mean by that? Um, so recall that last time what we did was we use rectangles to approximate area under the graph. And let's say I'm using n rectangles. So n is a number. It could be 5, it could be 10, it could be 1,000. And by taking n to infinity, so by taking n to be large enough, to be big enough, I'll get a better and better estimations. And so by taking n to infinity, the approximation will become the exact area. Does it make sense? So if I write this as a formula, so area under f of x using n rectangles. No. Area under the graph of f of x is, it would be something like the limit, but forget about the limit for a second. And let's think about what it would be inside the summation. So if you remember that each of the rectangle, for each of the rectangle, we have the width, right? And I call that delta x. And if you have the points xi, we calculate the height by plugging in to the function. So this would be the height of one rectangle. This is the width, again, for one rectangle. So when you multiply the height by the width, you get the area of one rectangle. So this whole thing, it gives you area of one rectangle. Now the next thing I want to do is to add up all the areas of the rectangles. So what I will do is I will put the sigma notation here. So this is the sigma notation. It means the summation over the index set I goes from 1 to n. So I'm taking n rectangles. That means I need to sum up n areas of rectangles. Does it make sense? So maybe do this. Purple, it means the sum of areas of n rectangles. And so when you take the limit, finally, when you take the limit, what should I use? Green, okay. It's a green here. When you take the limit n goes to infinity, the whole thing gives you the exact area under the graph. Any questions? Hello there. I guess I have to watch my video to see what we have discussed so far. But other people, any other questions? Okay. Um, so this thing that I just talked about, it's actually the hardest part on your webwork. There are like two questions. The second question is like several parts using different intervals. I can tell you that they are really tough to do, and I'm going to do one question for you, and then you need to repeat what I did, what I'm going to do on your webwork. So let's look at the first question on the webwork. Ah, okay, so this is webwork 4.2, question 1. So the question is, the limit of the sum of something is the limit of a Riemann sum of n subintervals of equal width with sample points equal to the right endpoints of the definite integral. Oh wait, I haven't told you what integral is. Sorry, my bad. Okay, so here's the definition. The integral of the function f of x dx from a to b. So that's the notation. We define that to be the area under the graph of f of x, which from our discussion earlier, this is the same as the limit of the sum of the areas of rectangles. So that's the definition. And then I should say that we call whatever that's inside the integral. So the whole thing is called the integral. The integral of f of x is. So the whole thing is called the integrals. And whatever that's inside the integral, it's called the integrand. And the a that I wrote here, this is the lower limit. And this is the upper limit. I should also point out, this is not very important, but I should point out that you keep the dx. You want to write the dx to keep track of the variable. So in this case, the variable is x. Is it okay so far? So the definition of the integral from a to b of a function is just the area under the graph. And but what we just discussed so far, it's the limit thing. It's the limit. Questions? Okay. Let's go back to the webwork. Okay, so the question says that the limit that you are looking at That's a limit of a Riemann sum of n subintervals of equal width, and the sample points are the right endpoints for the definite integral from 6 to 9. So the intervals, the lower limit is 6, the upper limit is 9. So the answer you're gonna put in would be the function. And here is how you find the function. So first step, point 2, question 1. So first step, you find the width first. Okay, let me write down the question. No, that's fine. Okay, so the first step is to find the width. So the width, the notation is delta x. What is the formula for the width again? So how do we find the width? Yes, I'm going to do that. So how do we find the width? I'm asking what is the width of each rectangle? Okay, upper limit minus lower limit. So in general, the formula is the length of the interval. So upper limit minus lower limit. And you divide that by the number of its rectangles. Assuming we are taking n rectangles, so the bottom is n, the top will be, in this case, it will be 9 minus 6, because the upper limit is 9, the lower limit is 6, so 9 minus 6, which is 3 over n. Is it okay so far? Okay. And second thing is I want to find my sample points. By that I mean sample points xi. So let's start with x0. So what do you think is the initial point? Okay. Let me know when you're done, Daniel. Should be the number of rectangles. Okay. Now the second step is to find all the sample points xi. Let's start with the initial point. So what is the initial point here? What is the point we start with? 6, yep. Because you're taking the integral from 6 to 9. So the first point should be 6. X1. So the first point is 6. The width is 3 over n right here. So x1 should be let me rephrase. So let me rephrase. So if I tell you that x0 is 6 and I tell you that the width is 1, can you tell me what is x1? Seven. So how do you get that? You add the width to x0. So add 6 plus 1. Does it make sense? So we get x1 by adding the width to x0. Okay, so what is the width again? So remember that when you compute the area of each rectangle, when you compute the area of each rectangle, you need the width of the rectangle as well. And the width of the rectangle would be the same, would be the distance between two sample points. And if I tell you the x0 is 6 and the width is 1, then the next point should be 6 plus 1. Does it make sense? And in this case, the x0 is 6, the width is 3 over n. So x1 should be 6 plus 3 over n. Make sense? Okay, so this is my x1. What about x2? What's n in this case? I say n is the number of rectangles. So for now, I'm fixing the number of rectangles. And at the end, I'm going to take the limit. No, I'm not saying 6 plus 3 over n is 7. I was just giving an example. So I was giving an example where the width is 1. I was saying that if x0 is 6, if the width is 1, then the next point should be 6 plus 1 equals 7. Yes, x0 is always the lower limit. Whew. Okay, let's take 2 minutes to answer your questions. So how do we approximate the area under the graph again? If we use a rectangle, it would be something like this, so on and so forth, right? And what is the width of a rectangle? The width of a rectangle, you get that by dividing the length of interval, the whole interval, by the number of rectangles. But it's also the distance between any two adjacent points, right? So for example, it would be the same as x1 minus x0. It's also the same as x2 minus x1, so on and so forth. Daniel, does it make sense? Yeah. So if I give you x0, and if I tell you that the width is 1, then what is the next point? Let me repeat the question. So if I tell you x0 is 6, if I tell you the width is 1, then the next point should be 6 plus 1, right? And in our case, I have that x0 is 6. Is it okay for you? Because the integral is taken from 6 to 9. Is it okay, Daniel? Okay. And we also know that the width is 3 over n. Are you okay with this? Okay. So that tells you that x1 should be the first point, sorry, the x0 point plus the width. Is it okay? No, your next point should be 7 plus 6 over n. Forget about what I just say about the one. That was just one example. It's not this example. Is it okay? Yeah. By the way, focus on my question first. So don't look at your verbal question. I think you guys have different numbers. Um, to make sure you're not confused with the numbers, make sure you focus on the question that I have. So x1 equals 6 plus the width, which is 3 over n. So 6 plus 3 over n is my x1. How do I get my x2? So how many 3 over n do I need to add to x0? So I need to add 3 over n again to my x0, which means I should have um, 2 times 3 over n. I need to add 2 copies of 3 over n to 6. Is it okay? Okay. And so x3 would be 6 plus 3 copies of 3 over n. x4 would be 6 plus 4 copies of 3 over n, so on and so forth. Do we agree? So what is xi? Xi would be 6 plus how many copies of 3 over n? I copies of 3 over n. So notice that these two index should be the same. Make sense? And so let's rewrite that. So this will be the same as 6 plus. If you multiply the I to the top, you're going to get 3 times I divided by n. Is that okay? Okay, now going back to the question, so inside the limit and inside the sum, we have something like this, right? Is it okay? Okay, now it just so happens that this guy is the same as our width, right? This guy is the same as this guy. And I know that inside the limit, inside the sum, it should be the width times the height. If this is the width, this guy should be the height. Make sense? On the other hand, I also know that the height can be computed by plugging in my sample points into the function f of x. So f of x is a function that I am going to find, and that's a function you're going to put into the integral. Is it okay? Is it okay? All right. So now I know that 6 plus 3i over n should be my height. And using the xi notation, so I know that xi, look at this one. So xi equals 6 plus 3i over n. By replacing 6 plus 3i over n by xi, I get that this is the same as the square root of xi. Questions? So that means f of xi is the same as the square root of xi. Yep. Which part? So I'm just rewriting the height in terms of xi. So the height is the square root of 6 plus 3i over n. I also know that for my calculation earlier, xi equals 6 plus 3i over n. So that equals whatever that's inside the square root. So plug that here, you get the square root of xi. Okay, and then this two should be the same. So I'm just writing them to be the same. So f of xi is the square root of xi, and it's the same for all the sample points. So f of x should be root x. And so that's a function you're going to put into the integral. This is the integrand. Is it okay? Okay. Um, I think I should do maybe another example. So second example. This is not from the webwork anymore. So suppose that I have this. No. Suppose that I have this. The question is find f of x. Yep, so the answer to the question is just root x, yes. All right, this is a second example. So suppose that the integral from 0 to 1 is that thing. And the question is, what is your f of x? I know some of you would guess that it should be 1 over x minus 2, but it's not in this case. And we'll see why this is not. Okay, so the first step, you find delta x, find the width. So what is the length of the interval again? Sorry, the width formula says that, to compute the width, you divide the length of the interval by the number of the rectangles. In this case, what is the width of the interval? It's just 1. So you do the we're taking the integral from 0 to 1. So 1 minus 0. And then you assume that the number of rectangles is n. So the width is 1 over n. Is it okay? All right. Second step, find the sample points. Let's call it xi. Let's start with f0. Yeah. Okay, so let's start with x0. What should it be? What's x0? It should be 0. So it should be the same as the lower limit, which is 0 in this case. And so x1 is, how do we compute x1? You know that the lower limit is 0, and you know that the width is 1 over n. How do we get x1? 0 plus 1 over n. So 0 plus 1 over n. And so x2 is, so how many copies do I need to add to x0? Yep, so 0 plus 2 copies of 1 over n, so on and so forth. You're going to get xi equals to 0 plus how many copies do I need to add to 1? Do I need to add to x0? I copies, so I times 1 over n. And if you rewrite that, you're going to get I over n. Is that okay? Cool. All right. So let's put everything back to the back to the question here. So I'm going to rewrite this. So I know that this thing right here, this thing that I just wrote, it should be the width multiplied by the height, right? Do we agree? Okay, so this thing should be the same as the width multiplied by the height. I know that the width is 1 over n, which means I need to first put the 5 to the top here so that this looks like the width. Is it okay? Questions? Okay, so once you do that, you can say that this is the height. So that should be your height. So that means, yeah, sure, I don't know how to spell. That means the height, which is the same as plugging in the sample points into the function, it should be the same as 5 over 5i over n minus 2. Is that okay? I'm not getting any response, so I'm not sure if you have any questions or not. Okay. The next step is to put that in terms of xi. And remember that my xi is I over n. And this thing right here, it looks like I over n. So replace that by xi. Which means, so f of xi equals 5 over 5 xi minus 2, which means f of x should just be the same as 5 over 5x minus 2. Questions? Which part? Matt, which part? From 1 over n to xi. You mean this? Wait, I don't get which part are you talking about? Is it this page, the first page, second page, or the last page?
I'm confused how you went from I over n to xi.
Oh, okay. So we computed that xi equals I over n, right? This right here. Yes. And my point is, this is exactly I over n. So that means I can replace that by xi. Yep. And the reason I want to do this is because I want to find a function, and the function should be in terms of x, not I, not n. Is that okay? So f of x equals that, and that's your function. And I think Daniel asked another question. So what was your question again, Daniel? Okay. Any other questions? This is taking way longer than I thought. It's okay. All right. So the second thing that I want to do is to compute integral using geometry. This should be easy for you. So I only have 2 examples. Let's look at this. So let's say I want to compute the integral of -4 to 4 of the square root of 16 minus x squared d of x. So that means I want to compute the area under the graph of y equals the square root of 16 minus x squared from -4 to 4. So this is the area under the graph of y equals square root of 16 minus x squared from x equals -4 to x equals 4. That was the definition. And what does it look like? What does y equals the square root of 16 minus x squared look like? Any ideas? Okay. So this is the same as y squared equals 16 minus x squared. So x squared plus y squared equals 16, which is 4 squared. And what is the shape? This is a circle center at 0 of radius 4. And the 4 comes from this. Make sense? Okay. So it looks like this. Well, it's actually not the whole circle. It's actually just half a circle because I'm taking the positive square root. So y equals that from -4 to 4. So I'm actually computing the area under the semicircle of radius 4. So this thing right here, it should be, what's the formula for the area of a circle or a semicircle? So the area of the circle of a full circle should be pi r squared. For a semicircle, it would be half of that. So pi times the radius is 4, so 4 squared divided by 2. Questions? All right. All right, one last question before I let you go. Second example. I have the integral of the absolute value of 2x minus 3 from 0 to 5. So that's the same as the area under the graph of the absolute value of 2x minus 3 from 0 to 5. So that means I need to draw the graph of the absolute value of 2x minus 3. What does it look like? It's a V shape. So the first thing you do is to find 2x minus 3. You want to find the root of 2x minus 3. So set it to be 0. You get x equals 3 over 2. And this point will be your 3 over 2. And then it will look like a V shape. Is that okay? So I'm only interested in the area under this thing from 0 to 5. This is not scaled properly, but that's fine. Okay. Now, what does it look like? So it's just two triangles, right? So how do we compute the area of a triangle? One half base times height. So let's look at the first triangle. What is a base? 3/2. So the base is 3/2. The height, so this thing, how do I compute this thing? Yep, you put x equals 0 into the original function, which is the absolute value of 2x minus 3. So when you put in 0, you get 0 minus 3, and then absolute value. So this thing, the height should be 3. Make sense? For the second triangle, what is a base? It's 5 minus 3/2. I'll let you compute that. 5 minus 3/2. What about the height? Which point do I plug in? Okay, you plug in 5, this 5 right here, into the function. You get 2 times 5 minus 3. So that's 10 minus 3, which is 7. And then you take the absolute value, but it doesn't do anything. So 7. And so the original integral becomes 1/2 times base times height for the first triangle, plus the same formula for the second triangle. And that's it. Any questions?